Okay, make sure you connect it, I guess. Why not? Even though this is not the end position of the triangle, right? That's just the first transformation. And then B, we are going to translate, which is slide it. Each point is going to slide x plus 9. So that means that it's going to move 9 to the right, and y plus 2 it's going to go up 2. Remember, you can just add to the x coordinates and add to the y coordinates, or you can count one at a time. Count 9 forward and 2 up. 9 to the right and 2 up. 9 to the right and 2 up. Probably I'm just going to get my coordinates. X prime is -3, -7. Y prime, -2, -1. And Z prime, -5, -2. And now each of them is going to move 9 to the right. Y is going to move 9 to the right, Z and X, and then also 2 up. So you can add 9 to all of these, and we get 6, 7, and 4. And then if we add 2 to the y coordinate, we're going to get -5, 1, and 0. And then this is our final position. It should kind of be more like x prime prime and y double prime z double prime, because it's our second composition. 6, -5. Hopefully you guys can see it. Whoa. 7, 1, 4, 0. Okay, this time it did not flip. Whoop. And there you go. Okay, x, oh, that's wrong. Z double prime, y double prime, and x double prime. So I'll probably add a prime to each of these. So first it reflected over the x, and then it slid 9 to the right and up 2. So that's the first example. They're pretty easy. You guys should kind of know how to do all of them, because it's what we've learned. You're just doing 2 at a time. If you don't need to watch the rest of the video, then you don't have to. If you still kind of are confused about the examples, then you should follow along for 2 more. And then for your homework, you guys have to complete from here down. So you have 1, 2, 3, 4, 5, 6 problems to do for Tuesday. Okay, so for number 2, we have a triangle, -1, 6, that's G, -1, 3 is H, and this one's I. A translation along the vector. Remember, a vector is a direction. It's just like coordinate notation, like the one that we did above. If it's positive, it moves to the right. If the second coordinate is positive, it goes up. And if they're negative, left, negative, down. So here we are going right 7 and down 5. Again, you can just add 7 to each x coordinate and subtract 5 to each y coordinate. So then G prime, H prime, and I prime. The first translation is gonna move it to 6, to, again, 6, and to 1, and then subtract 5, we get 1, -2, and 1. Okay, that is if we move it 7 to the right and down 5. 6, 1 is G prime. 6, -2 is H prime, and then I think I got 1, 1 for I prime. That's our first transformation, a translation basically with vector notation, right? Component form. And then for the second one, a reflection over y equals 3. Y equals 3 would be this horizontal line y equals 3. And don't forget, the reason why it's y equals 3 is because all the points have no, it's -3. I just saw that. So my bad, ignore that one. That one is +3, but we want to reflect it over y equals -3. So down here. So I kind of want to ignore this line. That was a mistake. It is going to reflect underneath y equals -3. And that's because the y coordinate is -3. This point is -8, comma, -3. Here's -5, -3. 0, -3. 2, -3. So the y coordinate stays -3. So it's just going to go from the top to the bottom. So if it, now we count to the line of reflection. H is 1 from the line, so it's going to be 1 underneath. So now we're going to get H double prime. G is 1, 2, 3, 4. So now it's going to be from here, from the line of reflection, 1, 2, 3, 4. G double prime. H is 1, 2, 3, 4. So now you start to count again from the line, 1, 2, 3, 4. And that's I double prime. And now your triangle reflected. And these would be our final coordinates after those two transformations. For I, or for G, let's start at G, we have 6, -7. For H, we have 6, -4. And for I, we have 1, -7. And that is our final coordinate. I think probably the hardest part is like if you guys don't remember what vector component form means, but it's just a translation. If you're not sure what y equals -3 looks like, if you drew it horizontally, then it would have been correct. But if you drew it vertically, then you would have reflected it from right to left. So make sure that you're being careful with your lines. And then last example, we have, so let me move it. It might move a little bit. This table's wobbly. Okay, we have rhombus PQRS. P is -1, -3, Q, R, and S. Translation along the vector 4, 10. Again, it's going to go 4 to the right because that's the x coordinate and it's positive, and then up 10 because that's the y component form. And again, you can just add 4 to all the x coordinates and 10 to the y coordinates. And that would leave the rhombus in the new position, 4 to the right and up 10. Okay, so P prime, if I add 4, Q prime, R prime, S prime. I'm gonna add another for the second transformation, but we add 4, we get 3, 7, 8. Okay, that's 3, that's 7, that's 8, and that's 4. And if we add 10, we get 7, 6, 2, and 3. Okay, that would be the position of the new rhombus after just a translation along that vector. We are at 3, 7 here for P prime, which kind of makes sense. It moved 4 to the right and up 10. 7, 6 for Q prime. 8, 2 for R prime, and 4, 3 for S prime. Still looks like a rhombus. It didn't change orientation, position, shape, nothing, because it just slid. So everything looks exactly the same size, same shape, and same orientation, right? And for the last one, a 90-degree counterclockwise rotation around the origin. So clockwise goes like this. If the clock is at 12, it's going to go to 3, right? 12, 1, 2, 3. That's clockwise. So I'm just going to put that in the corner of my paper. So if we are doing counterclockwise, that means that you're going to pick up your paper and it is around the origin, which is nice. So we're gonna pick up our paper and around the origin 90-degree counterclockwise. So that means it should go from being vertical to horizontal. I'm gonna pick up the water, okay, like this. And because we are starting at the origin, we're gonna start at 0, 0. That's our starting point. And you just kind of want to make your own directions to get to S, R, P, Q. And remember, we're not starting at the pre-image. Now we're after the vector translation. So to get to S, so from here, if I say left, I mean left, right, up, above this point now that the paper's turned, and down is below the origin. Okay, so from the origin, I'm just gonna call it C. From C to S, how would I get from C to S? I would have to go left, 1, 2, 3, so that's -3. And then up, 1, 2, 3, 4. To get to P, or P prime, S prime, P prime, I'd have to go left 7 and up 3. And then to get to Q prime, we would be going left 6 and up 7. And the last one, to get to R prime, you would have to go left 1, 2, -2, because it's left, and then up 8. And if you notice, I'm writing these with vector, right? With the sharp brackets, not parentheses, because they're not coordinates, they're directions. So now that you took those directions, you want to flip your paper back to its starting position, and you follow those directions from the center of rotation, which right now we're just starting at the origin. So I go left 3 and up 4. This is where S prime is at, double prime. Left 7 and up 3. This is P double prime. Left 6 and down 7. I think is what I wrote. Is that what I wrote? No. Shoot. It looks like it. Okay, let's start over. So it's left 6 and up 8. No, up 7. That's a 7. Okay, to get to Q, it was left 6. Whoops. To get to Q, it was left 6 and up 7. So that should have been left 6, up 7, and to get to R is left 2, up 8. Okay. So to get to, so now we were on Q, left 6 and up 7. So here is Q double prime, and then left 2 and up 8 is R double prime. And that is our final position of our rhombus. It turned, first it translated 4 to the right and up 10, and then it rotated 90-degree counterclockwise. So that's our final coordinates. For P, we have -7, 3. For Q, we have -6, 7. For R, we have -2, 8. And for S, we have -3, 4. And if you notice, remember that we talked about how if you do rotations around the origin, there is a pattern. So here you guys can kind of see that we're not looking at the original coordinates, okay? We're looking at after the vector, after it translated 4 to the right and up 10. So from here, these are the coordinates after the vector, after it translated with the vector form. And if you look at them, they did switch, right? They switched from 3 to 7 to 7, 3, 7, 6, 6, 7, 8, 2, 2, 8, 4, 3, 3, 4. And the y coordinate became negative. So it's in the front now as a -6, went to the front as a -2, as a -3, as a negative. So that means for 90-degree counterclockwise rotation, the rule, you can make a rule when it's at the origin, it is that you are going to switch them. It's going to be negative yx. So if you remember that rule, or you had your rotation rules, then you could have used it. But yeah, make sure you guys finish the rest of the homework for today, which is those like 6 problems.